In Osaka in 1730, rice merchants crowded into warehouses beside the river and bought harvests that did not yet exist. The grain might still be standing in distant fields, green beneath summer rain, but paper claims against it were already changing hands. Feudal domains had collected rice as tax, stored it in city warehouses, and issued bills that merchants could trade. At the newly authorized dojima market, men were no longer bargaining only over sacks they could touch. They were betting on future weather, future hunger, and the future price of Japan's staple. The numbers formed in Osaka did not stay in Osaka. Couriers and flag signals carried rice prices toward other cities. A change in one market could reach officials, brokers, landowners, and households far away. Samurai status and domain wealth were measured in koku, a unit based on rice. Taxes arrived as grain. Salaries could be calculated as grain. Political rank could be expressed as the amount of grain a territory was expected to produce. Rice had become breakfast, tax payment, paycheck, social rank, state revenue, and financial instrument at the same time. Compare that world with a supermarket shelf. A bag of white rice sits quietly beneath fluorescent light. It looks cheap and almost blank. Nothing about it suggests wetlands carved by hand. Merchants trading paper promises, enslaved engineers building tidal fields, colonial governments turning deltas into export machines, or scientists redesigning the plant to prevent famine. Yet rice became powerful for one simple reason. It could turn water, labor, and land into calories that could be stored, counted, taxed, transported, and controlled. Rice became more than a crop. It made rice a ledger. Every grain could record who owned the field, who commanded the water, who collected the tax, who ate first, and who was left with too little. The same plant that helped communities survive also helped rulers measure them. The same bowl that carried comfort could become a border between abundance and famine. The story of rice is the story of people reshaping wetlands, of two continents domesticating different species, of sacred terraces and imperial warehouses, of wealth built in mud, of nutrients polished away, and of a seed redesigned to feed a growing Asia. It begins thousands of years before Osaka, where the grain had one frustrating habit. It refused to wait for human hands. If you like stories where ordinary food turns into empire, trade, obsession, and hidden history, subscribe to Food Empire History. Now, to understand how rice became this powerful, we have to go back to where the story really begins. Long before rice was white, polished, measured into cups, or sealed in plastic, wild rice grew among reeds and shallow water in the Yangtze River basin. The landscape was not a neat grid of paddies, it was a shifting edge between river, marsh, mud, and seasonal flood. People gathered fish, hunted animals, collected plants, and returned to places where wild grasses produced edible seeds. Rice was one useful food among many, not yet the center of civilization. Wild rice, however, was difficult to control. When its grains ripened, the plant naturally shattered. Seeds broke away and fell into the water or mud, which was excellent for the survival of the plant and terrible for a person trying to carry the harvest home. A late arrival could mean an empty stalk. An unlucky movement could scatter the food before it reached a basket. Over generations, people changed that relationship. They gathered plants, disturbed the wetland, burned reeds, cleared patches with wooden and bone tools, and encouraged rice where it was easiest to harvest. The plants whose grains stayed attached a little longer were more likely to be collected and replanted. Human preference slowly became biological pressure. Rice began losing the wild habit that had once protected it. This was not a single afternoon of invention. Domestication unfolded over many generations, and the exact pathway remains debated. Archaeology and genetics strongly place the earliest domestication of Asian rice in the Yangtze region, with Japonica rice emerging first. Later, when domesticated rice moved into South Asia, It mixed with local wild or partly cultivated populations and helped produce the indica rice that now fills much of the world's long-grain market. The crucial transformation was larger than the seed. People also domesticated water. They learned to hold it, release it, channel it, and shape soil around it. A paddy field is not simply a wet field. It is an engineered agreement between slope, rainfall, mud, seedlings, bunds, canals, timing, and collective labor. Water must arrive when the young plants need it. Too little can ruin the crop. Too much can drown it. One broken bank can send a neighbor's water away. That pressure organized communities around calendars and cooperation. Seedlings were raised, transplanted, weeded, harvested, dried, threshed, pounded, winnowed, and stored. Every stage demanded knowledge, and every stage created a point where labor could be shared, commanded, or exploited. Rice was also domesticated independently in West Africa. African rice, Oryza glaberrima, emerged from a different wild ancestor and a different human history, probably centered around the inner Niger Delta several thousand years ago. It was not a lesser copy of Asian rice. Farmers selected it for African environments, and its story matters because later European colonists would profit from rice-growing knowledge that already existed in West Africa. By then, rice had revealed its first great power. A wetland grass could become dependable food only when humans built an entire system around it. The grain was small. The infrastructure was not. Once rice could be cultivated reliably, it entered places that calories alone cannot explain. It moved into ceremonies, songs, offerings, marriages, harvest rituals, and ideas about fertility and abundance. A successful crop did more than fill a granary. It confirmed that water had arrived, ancestors or spirits had been respected, neighbors had cooperated, and the community would pass through another season. In the mountains of what is now the northern Philippines, Ifugao communities created and maintained terraces that turned steep slopes into living stairways of water and grain. Their survival depended on more than walls of earth and stone. Forest, watershed, soil, labor, ritual, chant, pest control, and inherited knowledge had to work together. The landscape was agricultural engineering, but it was also memory made visible. Across rice-growing societies, the grain could become sacred without becoming rare. That is one of rice's unusual qualities. Spices often gained status because most people could not obtain them. Rice gained meaning because whole communities depended on it. It could appear in an offering to a deity and in the bowl of a laborer on the same day. It could symbolize abundance precisely because the threat of shortage was always nearby. Rice also fermented. Cooked grain, water, microbes, and thyme became rice wines and ceremonial drinks. Rice flour became cakes for festivals. Glutinous varieties became foods whose texture marked special occasions. The crop was no longer one product. It could be steamed, boiled, pounded, fermented, ground, puffed, wrapped, sweetened, or offered whole. Human culture multiplied the meanings of the same seed, but meaning attracts authority. Granaries are visible concentrations of survival. A ruler who controls stored grain can reward soldiers, support officials, survive a failed harvest, or punish resistance. A temple that receives rice offerings accumulates more than food. A landlord who takes part of the crop receives the farmer's labor in a form that can be counted. Rice therefore became an ideal state crop. It was divisible, storable, measurable, and essential. Land could be assessed by expected yield. Households could be taxed in grain. Armies could march because farmers had produced food that would not disappear the day it was harvested. Bureaucracies could turn muddy fields into columns inside ledgers. In Tokugawa, Japan, this logic became unusually visible. Domains were ranked through kokudaka, an assessment expressed in koku of rice. The value was not merely a pile sitting in one warehouse, it represented the productive capacity of land and therefore the political weight of the lord who controlled it. A powerful domain could be described through rice before anyone described its roads, forests, workshops, or people. This created a strange contradiction. Merchants, officially lower in the social order than samurai, became increasingly important because they converted rice into cash and credit. The warrior elite might receive income tied to grain, but city life demanded money. Brokers stood between the harvest and the people whose rank depended on it. The men who were supposed to possess honor increasingly depended on the men who understood prices. That is how rice became a social mirror. At the top, it expressed rank. In warehouses, it became finance. In villages, it remained mud, insects, bent backs, water disputes, and the anxiety of clouds that arrived too late. Rice did not spread across the world because everyone discovered the same taste at once. It moved through farmers, migrants, marriage networks, armies, religious communities, merchants, and empires. From the Yangtze region, it traveled into other parts of China, Korea, Japan, South Asia, and Southeast Asia. Different environments demanded different solutions. Some rice grew in irrigated paddies, some depended on rain, some survived in uplands, some stretched upward as floodwater rose. Each new landscape changed the grain. Short sticky rice suited certain foods and climates. Long-grain indica varieties became dominant across warmer regions. Aromatic rices gained value through fragrance. Farmers selected thousands of local varieties, each carrying a practical answer to a local problem, such as drought, cold, flood, poor soil, taste, harvest timing, or storage. Trade expanded rice beyond the places that grew it. Muslim merchants and expanding Islamic states helped move rice through parts of the Middle East, the Mediterranean, Eastern Africa, and the Indian Ocean world. European consumers encountered rice long before European empires controlled major rice frontiers. But rice was heavier and less spectacular than pepper, cinnamon, or cloves. It did not promise enormous profit in a tiny chest. Its power came from volume. To move rice at imperial scale required ports, mills, labor, and hungry markets. That system became brutally clear in British-ruled Burma during the 19th and early 20th centuries. The Irrawaddy Delta was transformed into one of the world's great commercial rice frontiers. Forest and wetland gave way to cultivated acreage. Migrants arrived, credit expanded. Mills rose near Rangoon. Steamships carried grain outward. By the first decade of the 20th century, colonial Burma was exporting millions of tons of rice and paddy. The grain fed people far beyond Burma. It went to India and Ceylon, to China and Japan, to Southeast Asian territories, and into wider imperial trade. Rice from one colony helped feed migrant workers producing rubber, tin, sugar, tobacco, and other commodities in another. One imperial crop supported the labor behind several more. The machine appeared efficient from the deck of a ship. Sacks moved down the dock. Mills removed husks and prepared grain for distant buyers. Ledgers showed rising exports. Colonial officials could point to commerce, shipping, and cultivated land as evidence of progress. The view from a debtor's field could look different. Expansion required money for land clearing, seed, tools, and survival before harvest. Farmers exposed themselves to lenders and unstable prices. When global demand fell, the field remained, but the promised income could vanish. Rice had connected rural households to a world market they did not control. The grain had completed another transformation. A local answer to seasonal hunger became ritual, rent, tax, political rank, and then bulk fuel for distant economies. The people who ate it never saw the delta. The people who grew it rarely controlled the price. Across the Atlantic, rice entered an even darker system. European colonists in South Carolina wanted a crop that could make wet lowlands profitable. They did not enter an empty landscape with complete knowledge. Many enslaved Africans came from rice-growing regions of West Africa, where people already understood seeds, soils, water management, processing, and the demanding rhythm of cultivation. Along the coast from the Carolinas toward Georgia and Florida, enslaved workers cleared forests and reshaped marshes. They built levees, dikes, ditches, drains, and floodgates. Tidal rice agriculture required precise control. Water had to enter and leave at the correct moment. The fields were dangerous, exhausting environments of heat, mud, insects, disease, and relentless labor. Plantation wealth grew from that expertise, but ownership of the wealth did not follow ownership of the knowledge. Planters sold rice into Atlantic markets and became some of the richest figures in British North America. The people whose skill made the system possible remained enslaved. Women were central to sowing, weeding, harvesting, pounding, winnowing, and preparing rice. Coiled baskets, processing techniques, foodways, language, and community traditions carried West African knowledge through generations. The plantation tried to reduce people to labor, but people preserved culture inside the work imposed on them. This matters because rice history has often been told as though colonists introduced technology to passive workers. In reality, rice cultivation in the American Lowcountry was a multicultural system built under slavery, and the specialized knowledge of enslaved Africans was indispensable. The straight lines still visible in former rice landscapes are not only evidence of planter ambition, they are monuments to forced labor and stolen engineering. Rice could also kill without a plantation whip. It could become lethal when access collapsed. During the Second World War, Bengal depended on a fragile food system shaped by harvest conditions, prices, wartime disruption, government policy, and regional trade. When Japan conquered Burma, a major source of imported rice disappeared. A cyclone and crop disease damaged production. Transport and trade barriers tightened. Prices rose beyond the reach of millions. The Bengal famine of 1943 was not caused by rice alone, and no single explanation can carry the entire disaster. War, market panic, inflation, failed distribution, colonial priorities, local policy failures, natural shocks, and the collapse of purchasing power all contributed. But the crisis became visible in rice. Grain still existed in markets, warehouses, or guarded supply channels, while people who had lost wages, boats, land, or bargaining power could no longer obtain enough to eat. That is the cruelest form of a food system. The grain does not need to disappear completely. It only needs to move behind a price, a border, a ration card, or a military priority that the vulnerable cannot cross. A bowl can be physically near and economically unreachable. After the famine, food security became inseparable from political legitimacy across much of Asia. Governments understood that a state could survive military pressure and still be discredited by an empty rice pot. Rice policy was no longer only agriculture, it was national survival. Industrialization changed rice twice. First, it changed the grain people saw. For most of history, removing the husk and bran required pounding, winnowing, and repeated labor. Mechanical mills could process far larger quantities. They produced uniform white rice that stored well, cooked consistently, and looked clean and prestigious. But the polishing process removed more than color. It stripped away nutrient-rich outer layers. In parts of Asia where people depended heavily on polished rice and had little dietary variety, beriberi caused weakness, nerve damage, heart problems, paralysis, and death. Modernity had made rice smoother while making the diet more fragile. In the Dutch East Indies, Christian Eijkman was sent to investigate the disease. Chickens fed milled white rice developed a paralysis-like illness, while birds given unpolished rice recovered. Eijkman did not immediately understand the full mechanism, but the investigation helped reveal that food contained tiny essential substances beyond protein, fat, and carbohydrate. Rice bran became part of the road toward the discovery of vitamins, especially thiamine. The lesson was unsettling. A machine could make food more desirable and less complete at the same time. The white grain looked refined because human eyes associated whiteness with purity and status. Yet something invisible had been removed. Industrial food was beginning to teach the world that appearance, shelf life, and nutrition do not always move together. The second industrial transformation happened in the plant itself. By the middle of the 20th century, population growth and repeated fears of famine pushed governments and scientists to demand more grain from every field. Traditional tall rice varieties could grow heavy seed heads, then bend or collapse when given large amounts of fertilizer. More fertilizer did not automatically mean more harvest. At the International Rice Research Institute in the Philippines, breeders crossed varieties in search of a shorter, stronger plant that could hold more grain. In 1966, they released IR8, a semi-dwarf rice, soon called miracle rice. Under the right conditions, with irrigation, fertilizer, pest control, and skilled farming, it could produce dramatically higher yields. The plant changed the visual language of the paddy. Instead of tall stems waving above modest grain heads, compact plants carried heavier harvests. Seeds were packed and distributed. Farmers tested them. Governments promoted them. The Green Revolution helped increase food production across Asia and reduced the immediate fear that population growth would outrun the rice supply. But miracles arrive with requirements. High-yielding varieties often depended on reliable water, fertilizer, credit, and access to markets. Farmers with irrigation and resources could benefit first. Local varieties could be displaced. Chemical use increased in many systems. A solution to hunger created new dependence on infrastructure, purchased inputs, and centralized breeding. Rice had become a scientific project on a continental scale. For thousands of years, farmers selected plants field by field. Now laboratories, governments, international institutions, and national extension systems helped decide which seeds would cover enormous areas. The grain had moved from marsh to temple, warehouse, plantation, colony, laboratory, and finally into a global system designed to produce hundreds of millions of tons each year. Today, rice remains the staple food of more than half of humanity. It appears as biryani, congee, jollof, sushi, risotto, paella, noodles, cakes, flour, vinegar, wine, snacks, and animal feed. It can be home in one kitchen and an anonymous industrial ingredient in another. The modern bag hides extraordinary diversity. There are fragrant grains, sticky grains, red rice, black rice, upland rice, deep water rice, drought-tolerant rice, and varieties bred to survive submergence or salty soil. Yet global markets reward uniformity. A small number of commercial types can travel farther and sell more predictably than thousands of local land races. The bag also hides water. Flooded paddies can suppress weeds and support production, but oxygen-poor soil allows microbes to generate methane. Rice cultivation is now a major source of human-caused methane emissions. The same water system that helped make rice reliable has become part of the climate problem threatening rice itself. Higher temperatures, erratic rainfall, drought, floods, and rising salinity already pressure rice-growing regions. Coastal deltas face saltwater intrusion. Farmers face higher labor and irrigation costs. A crop built around the controlled movement of water now lives in an age when water is becoming less predictable. There are answers. Alternate wetting and drying can reduce water use and methane by allowing fields to drain at intervals. Breeders are developing varieties that tolerate heat, drought, flood, and salt. Gene banks preserve seeds carrying traits that future farmers may need. Scientists study roots, microbes, fertilizer, and planting methods. Farmers continue doing what rice farmers have always done, adjusting a living system to unstable conditions. Yet the central conflict remains unchanged. Who controls the water, the seed, the land, the credit, and the price? A climate-smart variety means little if a farmer cannot afford it. A record global harvest means little to a family priced out of the market. A profitable export can exist beside local hunger. Rice can still be abundant in statistics and scarce in a bowl. That is why rice is one of the clearest ways to understand power. It reveals that food security is never only the amount grown. It is the ability to reach the food, pay for it, cook it, and trust that another harvest will follow. Take a handful of uncooked rice. The grains slide lightly between your fingers. They seem identical, quiet, and finished. But they are the end of a chain that began with wild seeds falling into Yangtze mud, and with African farmers shaping another rice species beside the Niger. They carry the memory of terraces held together by community labor, of granaries guarded by rulers, and of taxes counted in grain. They carry Osaka merchants trading the future, Burmese docks loading an imperial economy, enslaved Africans engineering tidal fields, families in Bengal watching prices rise beyond survival, millstones removing the bran, laboratory chickens revealing an invisible nutrient, and breeders shortening a plant to raise its yield. Rice fed cities, armies, workers, temples, colonies, and nations. It helped rulers measure wealth because it made life countable. It also exposed the limits of that counting because a government can record a full warehouse while failing to notice an empty home. When rice reaches your plate, water has already been moved, land leveled, seeds selected, weeds controlled, stalks cut, grains dried, husks removed, and markets crossed. The bowl looks simple because the system behind it has learned to disappear. That may be rice's greatest historical trick. It became powerful by becoming ordinary. Once people depended on it every day, whoever controlled its flow controlled more than food. They controlled labor, taxation, status, migration, credit, and the difference between calm and panic. So the next time steam rises from a bowl of rice, look at the grains before the sauce covers them. What appears blank is not empty. It is a ledger written in water, mud, science, empire, and human hands. If this story changed the way you see rice, subscribe for more hidden food history.